This question under thermodynamics. Okay, the question is saying that a gas is taken through the cyclic process described in the figure below. Okay, so we have been given the pressure in kilopascals, the volume in meter cubic. Okay, now as you can see here we have A, there we have B and C. Okay, so now the first question is asking us to find the net energy transferred to the system by heat during one complete cycle. Okay, so now as you can see, they want us to find the net energy transferred to the system by heat during one complete cycle. Okay, so the first thing which we're supposed to do, we're supposed to follow the directions. Okay, so we're starting from A, going to B, C, then back to A. So we're starting from A, going to B, going to C, and back to A. Okay, so as you can see, we have A, we're going to B. As you can see, the arrows. Okay, so A to B, then C, then back to A. Okay, so this is the cycle we are following. We are moving, starting from A, going to B, C, then back to A. Okay, so this is our cycle. So now, according to the first law of thermodynamics, we know that for any complete thermodynamic cyclic process, the system returns to its initial state, meaning that the total change in the internal energy is zero. Okay, according to the first law of thermodynamics. So what do I mean? We have the total internal energy, which is denoted by U. So total internal energy denoted by U is equal to the Q net, which is the heat net minus W net. Okay, so the W net, which is the work net. Okay, first law, or I can say according to the first law of thermodynamics, we know that for any complete thermodynamic cyclic process, the system returns to its initial state, meaning that the total energy in the internal energy is equal to zero. Okay, so the total energy in the internal energy denoted by U is equal to zero. Okay, so if the total energy by the system is equal to zero, meaning that the change in the total energy is equal to the Q net total energy of the system is equal to the Q net minus the work energy net. Okay, so I mean, since we know that the total energy, or I can say the total internal energy, is equal to zero, so meaning that the net energy transferred to the system by heat in the form of the Q net is exactly equal to the work done by the gas. Okay, so work done by the gas, which is the W net. Since we know that our change in U, which is the internal energy, is equal to zero, so Q net minus W net, when you cross this to the other side, so meaning that Q net will be equal to W net. Okay, according to first law of thermodynamics. So now the next thing which we're supposed to do, we're supposed to find the net energy transferred. So we're supposed to find the net energy transferred. Here we have 6, there we have 10. Okay, then here we have 2, there we have 8. Okay, so meaning that there we have 8, here we have 2, we have 6, we have 10. Okay, so to find the net energy, we're going to use the formula for the area of a triangle. So you know that the area of a triangle is equal to half BH. As you can see, here we have 10, there we have 6. So you just subtract 10 minus 6. So 10 minus 6, we're going to get 10 minus 6, we're going to get which is what? 10 minus 6, which is 4, times our height times height. So since here we have 8, there we have 2, so you're going to subtract what is 8 minus 2, which is equal to 6. Okay, so which is equal to 6. Once you multiply, you're going to get 12. Okay, so which is 12.0 kilo joules. Okay. So our net internal energy will be equal to so say Q net is the same as the weight net, which is the W net, is equal to 12.0 kilo joules. Okay, so that's our answer. Now the next thing, the next question is saying that if the cycle is reversed, okay, so meaning that we are moving in a counterclockwise direction. Okay, so we are moving in a counter clockwise direction. So our second question, which is B, we are moving from A going to C, going to B, going to A. We are moving in the opposite direction. Okay, so meaning that our Q net will be equal to the W net. We're moving in a counterclockwise, which is the opposite direction. The first question, we are moving in a clockwise direction. Okay, so here our net energy will be equal to negative 12.0. I can say 12.0 kilojoules, 12.0 kilo